Hello, welcome back to another vector video in Calc 21C, and this one is going to be about vector multiplication. So there are multiple ways to multiply vectors, but today we're just going to be talking about dot and scale. I think these are the two most multiplication-esque ways of operating vectors. So I'm going to start with I think the scalar is easier, scalar multiplication, and that's just multiplying a vector by a scalar, which is that's what scalar means. So I'm going to show an example to describe it more. But let's say this vector 5, 4, 9, random vector, and it's going to look something like, if you remember, let's say I'm going to draw the a graph, 3D graph right there, and from the origin to x5, y4, and then z9, so something like all the way up here, but like higher. And then the vector is looking something like this. It's coming towards us. This is how the vector would look like, something similar. It's just a rough draft. So this is a vector. It looks like this. Imagine if we multiply the whole vector by 2. That means we're doubling the length of the vector. So that means it's going to become this, but it's going to double up. So it's going to look like this instead. And these points are probably 10, 8, 9. Remember x, y, z. I mean, not 9. 18. And how I know that is because of the scalar multiplication. If you multiply this out, scalar is just, it goes into all of them. It goes into 5, it goes into 4, and it goes into 9. So it becomes 10, 8, 18. And this vector is the point. So it's this point over here, look, they look the same, which means it's just the point origin from the point origin all the way up to this point, and that's what this vector is. And that's basically the scalar. It's just scaling of a vector, like either making it larger or making it smaller, because you could also multiply it by 1/2, and you'd get 5/2 and 4/2, which is just 2, and then 9/2. And what it'll do is it'll just make it shorter, half length instead. And that's what a scalar vector is. And these another important trait to associate the scalar vector with is that so look at all these 3 vectors. This is the original one, this is double the original, this is half the original. They all have the same direction. So that means this is the direction of this is a direction vector. And scalar, when you multiply a direction vector by a scalar, it gives you a parallel vector. And as you can see here, the parallel vector, all of them are all parallel to each other, and they're never gonna intersect. And that's how you can find a different vector that's parallel to original. You can just find the scalar of it. And now for dot multiplication. Dot multiplication of a vector is exactly how the addition and subtraction was, but multiplication instead. So I'm gonna come up with different vectors. So 2, 1, 2, and then the next vector would be should I use 5 again? 5, 3, 0. To make it different. So a multiplication vector is just this vector multiplied by this vector, and the x's go together, the y's go together, the z's go together, and it looks something like x, y, z. So 2 times 5, and then 1 times 3, and then 2 times 0. I'm gonna use dot instead because they call it the dot vector. Dots is multiplication. And 2 times 5 is 10. 1 times 3. And and 2 times 0 is just 0. So the solution to the dot product would be 10, 3, and 0. And dot products, the use of dot products, later on I can make a video about it in the future, and later on you find out in the class, is that it's used to find the angles. So there's a formula for angles where it's cosine of theta is equal to u times v. This is dot product over I think the length of u times the length of v. That's how you find angles, and that's what dot products are, as you can see up here. And that's majority of the time what you're going to be using dot products for in this class. So that is the dot product and the scalar vectors and their applications. And usually dot vectors, instead of leaving your answer in just vector form like that, it's usually added up. So 10 plus 3 plus 0, and you get 13. So the sum of a dot product between two different vectors should be just a regular number. In that case, you can put it into this equation and just get a number over the length is also another number times another number, which should give you a number. And then to find the actual angle, you just cosine inverse of both sides, and then the angle is equal to a number, like it should be degrees.